Good day, class. Welcome to another lesson. The topic today is elements and chemical bonds. My name is Jenny, and I love science. I like to make videos to help you understand concepts in chemistry, biology, and physics. To receive my latest video, please subscribe and click on the bell icon to be notified as they are posted. How do elements combine to make chemical compounds? Bonds form chemical compounds. Elements combine to make compounds, just like letters in the alphabet combine to make new words. But in order to understand how elements combine to make compounds or to make bonds during a chemical reaction, it is important to know how the elements are organized in the periodic table. Elements are organized in periods or rows. There are a total of 7 rows in the periodic table. They are also organized in groups or columns, and there are a total of 18 columns in the periodic table. The periodic table lists elements according to the increasing atomic number. The atomic number increases from left to right. The atomic number is the number of protons in the atom of an element. How is an atomic number different from an atomic mass? The atomic number is the number of protons in each atom of the element, while the atomic mass is the weighted average mass of all the isotopes of that element. What do atoms create when they combine? In nature, it is rare to find pure elements. Instead, atoms of different elements combine to form compounds. Compounds make up most of the matter around you, including living and non-living things. There are only 115 elements in the periodic table. These elements combine to form millions of compounds. Chemical bonds hold together these compounds. A chemical bond is the force that holds two or more elements together. How is an electron's energy related to its position in an atom? Remember that atoms contain protons, neutrons, and electrons. Each proton has a positive charge. Each neutron has a neutral charge or no charge, and each electron has a negative charge. The atomic number of an element is the number of protons in each atom of that element. In a neutral or uncharged molecule, the number of protons equals the number of electrons. The exact position of electrons around the atom cannot be determined. This is because the electrons are in constant motion around the nucleus. However, each electron is usually in certain areas of space around the nucleus. Some of the areas are close to the nucleus, and some of these areas are further away from the nucleus. Different elements in an atom have different amount of energy. In the nucleus, the electrons move at a distance around the nucleus with different amount of energy. Areas of space in which electrons move around the nucleus are called energy levels. Electrons closest to the nucleus have the least amount of energy. They are in the lowest energy level. Electrons farther away from the nucleus have the greatest amount of energy, and they are in the highest energy level. This illustration shows the electrons at the lowest energy level, and they only hold 2 electrons. In the second energy level, the electrons that can be held are a maximum number of 8 electrons. Why are electrons farther away from the nucleus able to interact with other atoms? They have a weak attraction to the nucleus, so they are able to interact with other atoms. Imagine 2 magnets. The closer they are together, the stronger the attraction to the opposite ends. The negative charge of electrons have a similar attraction to the positive charge of the nucleus. The electrons in energy levels closest to the nucleus have the same amount of a strong attraction to the nucleus. However, electrons farther away to the nucleus are weakly attracted to it. This amount of electrons can easily attract to the nucleus of all the atoms. This attraction between positive nucleus and one atom of the negative electrons of another is what causes a chemical bond. Do electrons that are close to the nucleus have a strong attraction to it or a weak attraction? They have a strong attraction. Do the electrons that are far from a nucleus have a strong attraction or a weak attraction to it? They have a weak attraction. Do you think it will be easier for electrons to interact with other atoms if they have a strong attraction to the nucleus or a weak one? It will be easier for electrons with a weak attraction to the nucleus to interact with other atoms because the nucleus doesn't pull them as strongly as it does to other electrons. Which electrons are then free to participate in a chemical bonding? The electrons that are the farthest away from the nucleus are known as the valence electrons, and these are the electrons that participate in a chemical bonding. What are valence electrons? In Latin, valentia means strength or capacity. A valence electron is an outermost electron of an atom that is participating in a chemical bonding. Why it is useful to know the number of valence electrons in an atom? The number of valence electrons can be useful to determine the number of chemical bonds possible. You can use the periodic table to determine the number of valence electrons by looking at the group numbers at the top of each column. I would love to hear from you. Please add your questions in the comments section below, and I will answer them personally. In conclusion, when atoms form bonds, they gain, lose, or share valence electrons. By forming bonds, atoms become more chemically stable. Thanks for your support, and you'll see me in the next video. Bye!